Okay, then next is using the a minus b bracket square. So the um, unique identity is over here. Now instead of plus, it's a minus. Okay, this is where we kind of disregard whether it's a negative value or not, because the identity already takes in that negative value. So we look at 2x squared minus 16x plus 32. Now, actually for me right here, I will ask myself if the coefficient here is square rootable, right? And of course, everything can be square rooted, but there are some numbers that are not so nice, which is like 2 things that are not perfect squares. So we don't want to have these perfect squares, right? But what we can do is I can see there is a common factor of 2 throughout the 3 terms. So I'm going to factorize 2 out of all of them. Doing this allows me to do some factorization later, and be able to like use square root better at an easier level. And what you have here is this factor of 2. Now, many students tend to take away this factor of 2 because they assume it's an equation. However, the problem with it is that the 2 needs to be there because this is an expression. We are trying to maintain the value, and all we want to do now is to factorize this guy using the identity, which if we look carefully, it will be the 2 here. This will be x squared minus 2 times of x times 4, right? So that's 2ab plus 4 squared. And that is your a squared minus 2ab plus b squared over there. Okay, so you all need to play with the 2ab term and kind of like figure out it as well. So from here, we factorize it, and this will simply be x minus 4 bracket square. And the 2 still remains because you factorize the 2 out, it doesn't mean the 2 disappears. Okay? Now we move on to a little bit tougher thing, so which is something like that. Now the choice is actually given to you if you really want to factorize something out, but there are certain things that are not necessary. So in this case, I have very nice numbers here that are square rootable, 36 and 4 and 9. These are nice numbers, these are perfect squares that we can square root them. So we're going to start from here. Definitely a 6 square here. We're going to have 2 here, and we're going to have 6 here. Now this is a very big problem because 2 times 6 is 12, but we need an 8 instead. So we need to somehow be able to get a number that gives us 8y, right? So what I'm going to do is I'm going to take 8 divided by 12. Okay, the y definitely will exist there, and this will give me 4 over, no, this is not, this will be 4. Divide by, oh yeah, this is 4. This is 2 over 3, right? So in fact, my b term could be possibly 2 over 3y. Or so some of you may write it as 2y over 3. Now you need to ask yourself whether this, and this, when you multiply together, does it give you this guy, right? And that's the goal of it. You're trying to create that 2ab term according to the identity. Now we look at your b square term. It will be 2y over 3 square. So it's 4y square over 9. So this is how it goes, right? And if you think about it, if you square all these numbers, so 2 square is 4, y square is y square, 3 square is 9, that gives you your 4y square over 9. And that you will have, you take your a, which is 6, and your b is minus 2y over 3 bracket square. Okay, the last one over here is a little bit more challenging, but as I said, they are all very nice coefficients here, 81 and 4. So let's go ahead and do them. So this gives me 9a bracket square minus 2 times, I definitely need a 9a over here. And this is 18a, so I will have is 2b. And from here, I'll have 2b bracket square. Right, so because 2b bracket square gives me 4b square. So from here, my factorization will be 9a minus 2b bracket square. Easy peasy. Right, see ya.